All right, today we're going to talk about a super powerful tool for turning a giant, messy spreadsheet into a clear, simple story. It's called the box plot, and we're going to see how this one little chart can tell you so much with just a single glance. You know the feeling, right? You're staring at this sea of numbers, and you just know there's an important answer buried in there somewhere. It's overwhelming. The real trick is figuring out how to cut through all that noise to find the actual story. And that's exactly where a good chart, especially a box plot, becomes your best friend. Okay, let's make this real. Imagine we're looking at a medical study. We've got all this data on patient recovery times for a few different treatments. Now, how can we quickly figure out which treatment works the fastest? Or, which one is the most consistent? This is the exact kind of puzzle a box plot is built to solve. And here it is, our solution, the box plot. You might also hear it called a box and whisker plot. It's this incredibly elegant tool that takes a whole bunch of complex data and boils it down into one simple, powerful graphic. The best way to think about a box plot? It's like a story summary for your data. You get all the main plot points without having to read every single number. So how is this story summary actually written? Well, let's break it down and build one from scratch. To really understand the story a box plot is telling, you got to learn the language first, right? So let's do that. We're going to build one together, piece by piece. And I promise it's way more straightforward than it looks. Everything starts right in the middle, with something called the median. So if you lined up all the patient recovery times from the shortest to the longest, the median is the number that's smack dab in the center. A median of 12 days means half the patients got better in 12 days or less, and the other half took longer. It's the 50-50 split point. It's the heart of our data's story. And on our chart, the median is just this, a single line. This is our foundation, the central point that we're going to build the whole rest of the story around. Okay, next up, we draw a box right around that median line. This box is really, really important because it's going to show us how spread out or consistent the main chunk of our data is. It gives that median some much-needed context.
Now, this box has a fancy name, the interquartile range, or IQR for short. But all it really represents is the middle 50% of your data. Think about that. It shows you where the bulk of your typical results are, completely ignoring the crazy high or low values for a second. To get it, we just need to understand quartiles.
It's super simple. Imagine taking all of your data points and just chopping them into 4 equal groups, like cutting a pizza. Each of those slices is a quartile, and each one holds exactly 25% of your data. And that brings us right back to our box. See, the box itself is just those 2 middle slices of the pizza. The bottom edge of the box is the first quartile, we call it Q1. And the top edge is the third quartile, or Q3. So that box literally shows you the range of the entire middle half of your data. All right, we've got our median, we've got our box. The last thing we need to add to this structure are these lines that stretch out from the top and bottom. We call them whiskers. So what do the whiskers do? Well, they show you the expected, kind of reasonable range of your data. They stretch out to capture most of the data points, and they help us define what's a normal outcome versus what might be unusual. So you might be wondering, how far out do these whiskers go? Well, there's a standard rule everyone uses. First, you figure out the size of the box, the IQR. Then you multiply that size by 1.5. That number sets your boundary. The whisker then stretches all the way out to the last actual data point that's inside that boundary. It's a really clever way to define the expected range. So what happens if a data point falls outside the whiskers? That's what we call an outlier. These are the exceptions to the rule, the real surprises in your data. And honestly, they are often the most interesting part of the story, those weird cases that you definitely want to go take a closer look at. Okay, we've learned the lingo, we know the anatomy of a box plot. It's time to put on our detective hats and go crack the case. Let's go back to that medical study and see what the story of treatment A really is. We've got all the tools we need now. We understand medians, we get what the box means, and we know about whiskers and outliers. So let's take a look at the box plot for treatment A and finally read its story. Let's break this down. First, check out the median. It's right at 12 days. That tells us a typical recovery is pretty quick. Now look at the box itself. See how it's kind of short and narrow? That's huge. A narrow box means recovery times are really consistent. Most people recovered in a tight little window. And finally, the whiskers show us the full range goes from 8 to 19 days, with no little dots outside of them, so no extreme outliers.
So there's our verdict. Just by looking at that one chart, we know that treatment A gives a fast and, maybe more importantly, a very predictable recovery. We just turned a whole spreadsheet of numbers into a clear, actionable insight. That is the power of a box plot.
And just like that, you've got a new data superpower. You can now look at one of these charts and immediately see the story it's trying to tell you. So let's just recap what a box plot shows you, all at once. You see the data center, that's the median. You see the spread of the main chunk of data, that's the box. You see the typical range, those are the whiskers. And you can spot any unusual values, the outliers. And maybe the best part, it's an amazing way to put multiple groups side by side to compare them instantly.
So the next time you see a box plot, you're not going to be intimidated. You're going to see a story waiting to be told. So the only question left is, what stories are you going to uncover? Thanks for joining us for this explainer.